Okay, hello everyone, and thanks a lot for joining me for this talk. First of all, thanks a lot to Android makers for making this conference still possible, even though it's virtual. Just to present myself quickly, my name is Xavier Gouchet. I'm a senior software engineer at Datadog in France. You can find me online with my handle Gouchet at Twitter, GitHub, and SpeakerDeck. The slides for this talk are available already on the conference platform and on SpeakerDeck. So if the video gets blurry or fuzzy, you can download them and follow directly with the same slides. And of course, feel free to ask any questions on Slido, and I'll answer them at the end of the talk. First, to give a quick view of what Datadog is. Datadog is a monitoring platform that allows you to track and get information on metrics, logs, traces across organizations, across architectures, and it's offering overall 350 integrations, including Android and iOS. But we'll talk more about that a bit later. The topic for today is going to be performance benchmarking, and we're going to have a quick few words about what we're meaning about that. Performance usually means how well a computer, a machine, or in our case, an application works. And usually it goes with speed. A performant application does its work fastly. So mobile app performance today is still critical. There are many reasons for that. Though every year we get new devices with more RAM, with faster CPUs, with more disk space, and we have like faster network, 5G, possibly 6G next year or so. People might still be using low-end devices or slow networks. In average, people are going to change their phones every 3 or 4 years, meaning that most of your user base today are going to have devices that were released 3 or 4 years ago. This means that they might not have the latest Android versions, they might not have a fast device either, and some of them might even be working on a slow network. Like, for instance, I'm working from Normandy with a very, very slow network. I almost barely have 4G. Also, one thing that's very important is that people have a very short attention span, meaning that if your application takes 5 seconds just to start or to get information to them, they might get bored and install it and go to a competitor. So performance is still critical today. And performance on Android is fragmented. As I said, people might be using an old device. So even though you're working and you have a Pixel 4 in your pocket, you need to make sure that your application works correctly and smoothly on an old device. Say, for instance, a Samsung Galaxy S7, which was released 4 years ago and is still one of the most used Samsung devices out there. Good thing is that your performance can be measured, and it should be measured. The idea is that whenever you want to improve the performance of your application, you can just do it on a hunch. You need to know what you're working with. People, your users, are going to tell you whenever your application is not performant enough. You're going to get low ratings, you're going to get comments, you're going to get people on Twitter saying, oh, this app feels slow. And this is exactly what your users should tell you. They need to tell you if the application feels slow. But the measurements are going to tell you what part is exactly slow. And your users can tell you that. Also, when you do changes, when you write, you refactor some part of your application, you need to measure things. Measurements are going to tell you how much your pull request improves your performance. So if you think, oh, I need to improve this thing in my application, you need to measure it first without your improvement. Then you write your code, your improvements, your refactoring, or whatever, and measure again. And then you're going to see that your PR improved by 20% or 200% or actually against all odds, it actually decrease your performance. Back in 1974, Donald Knuth said, premature optimization is the root of all evil in programming. And that is, most of the time, it's true. I would amend that to say that first, you don't optimize early, but you should optimize eventually. Because, of course, you need to first know that your code works as intended, that it does the correct thing. So you don't need to make it work fast if it doesn't do the right thing. But once you proved that it works fast, that it works correctly, then you can make it work fast. And in your toolbox, you have lots of things to know if the code works and works as intended. You have unit testing, instrumented testing, manual testing, mutation testings, and all kinds of testing to know that, yes, the code does exactly what I want it to do. But what do you have in your toolbox to make sure that it works fast? This is exactly the topic of our talk. So the first tool I'm going to mention are the developer tools. These are the tools that are available right out of the box in Android Studio and in the Android SDK. The idea is that with these tools, you're going to be able to have a full view of whatever is happening on your device, including the network, the CPU, the heap, the rendering, and of course, your application. So the tools I'm going to mention today are the Android Studio Profiler, the systrace tool, and the Perfetto tool. The Android Profiler, there are like a lot of talks and blog posts out there on how to use it. The idea is that this is a panel that exists within Android Studio and monitors the CPU, memory, network, and energy level or any energy usage on the device that you're currently using. So either an emulator or a device that's plugged to your computer. And the good thing is that you see in real time the effect that your application or that the scenario you're playing with on the device, what effects it has on the device itself. You know when the CPU is intensively used, when the network calls are made, when the memory is used or released, and whenever some calls drain the battery. One good thing too is within the CPU part of the profiler, you can start tracing all the method calls in your application, meaning that you can say that you can get this call chart that's going to tell you, yes, I'm on this short time frame. I know exactly every single method that is called within my application, and you get this stack of method calls, and this view can tell you which methods take long time, and so this can tell you which methods are taking and needs to be reworked. Then you have the systrace tool. Systrace tool is a Python script that comes with the Android SDK. It can be launched like very easily, just launching the Python script directly. And when you start it, it starts tracing and starts listening to a lot of events that are happening on the device which is connected to ADB. And when you enter, it's going to complete the results and write a very nice HTML page with all the results combined. The idea is that you get a very, very full view of the CPU usage and everything that happens on every single threads in your application. Just to give you a quick view, this is what this tool looks like. As I said, you can view everything that's happening on every methods, every application that actually running on your device, and not only your application. You get to see what's happening for all the CPUs. You get to see every single threads. You have some integrations that are very nice to know what's happening during the animations. So you know that some animator happens here and there. You can get information about that. You get to see what's happening on the render threads, the main threads, the OKHTTP network calls, the RX stack. You get all of this in this tool, which is very, very useful. But the UI is a bit complicated to navigate. The Android guys made this new tool that's called Perfetto, which can reuse the same information created by systrace, but can also create their own and gets even more information. It's only available on IPA 28, which is Android Pie, which is nice because you can get an Android Pie device in an emulator, and most chances are if you're an Android developer, you can get an Android Pie device very easily. And so this tool is very, very nice. So you can get the same kind of information, but in a better looking UI. And the most interesting part of it is this tool that allows you to specify exactly what you want to listen to and what you want to look at in your trace view. So to give you a quick view, you get this wizard that says you want to listen to some specific things in the CPU, in the GPU, on the battery. So when the battery is drained, when the voltage and frequency change, when the memory is used, when there is low memory, and all sort of information. You can also debug some specific information on your application. You want to just debug the graphics or the video, the camera, the network, vibration, and all sorts of stuff. And once you've done and you've customized what you want to look at, you get here this full instruction set that allows you to copy and paste that inside a shell terminal, and this is gonna record exactly the trace that you want to have. And when you do that, you get this very, very nice looking UI, allowing you to you can add specific threads to to favorites to compare them side to side. You can have a very nice search here to search for specific occurrences of a call or a specific thing. You get all your CPU's view, and you get a very, very complete view of what's happening on your device. If you want to, you can also add additional information. So we've seen a lot of blocks that are automatically tracked because the tool knows how the Android system works. If you want to have custom blocks of information, you can also create those using this very, very simple code here. You just need to call trace.begin section with the name of your block and end it after you've done your work, and it's going to appear in either in systrace or in the Perfetto UI. So those tools are very, very nice because there is almost no setup required. You can, in a single click, single line of code, you can start getting information from your application. And you get full system state information. You get the network, you get the battery, CPU, memory, you get everything inside the device. This is very nice because you can control the scenario, you can control the environment. You want to have like a specific emulator, specific device, you can do whatever you want. Bad thing about that is that the performance measurements are skewed. This is due to the fact that because everything is tracked, the CPU is going to run slower, meaning that all your code is going to run slower. So the measurements are not going to be usable as absolute, but as relative value. You can know which part of your code takes the longest time, and you can say, you can't say that because Perfetto says I spent 50 milliseconds in this method, you didn't really spend 50 milliseconds because the whole thing is slowed down. The bad thing about this too is that it needs manual trigger. So you need to start tracing and then do your work and then stop the tracing, which can be difficult if you have very tight things to track. And also the UI that you get is very complex and dense. You have a lot of information. So finding the exact information you want to get can be difficult to get. When to use it? Usually you're going to want to use it if you have a specific performance issue and you want to first analyze what's happening in your code. You can also use it when you want to optimize a specific part of your code and you don't know exactly what is slow, or when you want to debug a tricky algorithm. So for instance, if you have nested loops, if you have concurrency, using the tracing, you can actually get a view of what's happening and how you jump from one method to a nested call, which can be very, very interesting and can be simpler to visualize than adding breakpoints and trying to follow the algorithm as it unfolds. If you want to go further, there is a tool on Android devices in API 28 or plus, which is like in the developer settings, you can add a tile in the tile settings to start a systrace on the device without it being attached to a computer. So if you're like using your application in the wild, like in a subway, in a train, or outside, and you're noticing some bad behavior, you can start a systrace from the device, then perform your manipulation that you want to analyze and end the systrace, and then you can retrieve the systrace from the device and analyze it later, which is very, very useful. The second tool I'm going to talk about is the benchmark tool, which is a Jetpack library used to standardize performance measurements. The idea is that you're going to measure timed performance of specific operations. The idea being that you're going to have some operation that you're going to do over and over and over and over again, and you measure each run, and then you can compile the information that on average, this method is going to take 10 milliseconds or 20 milliseconds or 1 second or who knows. So it's a Jetpack benchmark library. It's very easy to add to your project. It's just a single line to add the dependency in Gradle. And you need to also add a line in the Android configuration to use the benchmark instrumentation runner, which is based on JUnit 4, which is still the JUnit that we need to use for instrument testing. And once you do that, you can create a basic test class, which is like running with your Android JUnit class as always. And the benchmark library gives you a benchmark rule, which is what we're going to use to start measuring things. The idea is that when you write some tests, you can create a measure repeated block. And everything that happens in this block, which is a lambda in Kotlin, it's going to be repeated. And every time it repeats, it's going to be measured. And you're going to get the full timing in nanoseconds of how long this block took. And so you can know it's going to be repeated over and over again. And the library takes care to know how long, how many times it needs to be repeated. But then you can get information on average, how long did it took to do some work. Sometimes because this is repeated, you're going to need to reset the state of your system and the test. So you need to clean up some things within your block. You need to create some new data to pass to your methods. But you only want to measure the do some work call and not the clean state and create data, because these are not part of what you're testing. So there is this run with timing disabled method that, again, you can pass in a lambda to do some work, and everything within the lambda is not going to get measured. So on my first call, the clean state is not going to be measured however long it takes. And on the second call, the create data, the result of create data is going to be passed to the value data, meaning that you can create some fake data for your test and extract it and not measure how long it takes to create the data. To run it, it's as simple as running an instrumented check, as we always do. Just run the connected check task with Gradle, which is going to display this on your device or emulator. And then you're going to get the result in a JSON file with full timing information in nanoseconds. This is the kind of result that you can get. You're going to get a bunch of JSON object that looks like this with the class name and test name of what was measured. And then you're going to get in the metrics a full information on how long it took. The runs array is going to list the timing in nanoseconds of every single run that was done by the benchmark library. And you already have the minimum and maximum duration in nanoseconds again, and the median duration, which is not the average, but it's the one in the middle of all the runs. You can, of course, run it in the CI, which is a very interesting thing to do if you can use real devices. Based on our experience, emulators can be sometimes unstable depending on the container in which they're running. So if you have access to a device pool, you can use that to have more accurate results. You might need some tweaks in your Gradle config, but I have a link at the end of the presentation to with some information on how to make your benchmark test work in a CI environment. And then you can parse the JSON to either graph the evolution of performance or fail if the measurements exceed a threshold, which this later one is what we are doing in Datadog, because some of our code might run on the main thread, and we don't want these calls to take too long. So we make sure that they stay below a given threshold. And if a change, a refactoring makes them go over, it means it takes too long and we failed the build. So the very nice thing about Jetpack benchmark is that it's reliable and consistent, because the information, the same code is going to be run again and again and again. You're erasing some randomness in the results. You're going to get a measure that's smoother. Also, you can measure exactly just what you want, because you can be as high or low level as you need. Sometimes you can write a benchmark test on a single method in a single logic class, and sometimes you can write a benchmark test on what happens when you tap on a specific button in the UI, and how long this tap takes to get treated. The cons are on this library that you should run them on real devices. As I said, emulators can be flaky. So the results you get on the emulators need to be treated with a grain of salt. Also, the feature to be tested needs to be repeatable and called from code, because the idea of benchmark is to repeat the same code over and over again. You need to be able to reset the state every time you want to run the code you want to test. And of course, it takes a long time in CI, because again, this is repeated over and over and over again, meaning that every test that you measure is going to be repeated at least 50 times, meaning that it can take a long time to run. So when should you use it? You can use it to monitor critical part of your logic in the CI, which is what we do, as I said. You can measure how long some specific and critical parts of your code take to compute, and to make sure that it's not going to slow your main thread. You can use it to refactor a specific feature. As I mentioned in the beginning of this talk, when you do a refactoring, you want to measure before and after. So you can do a first run with the benchmark library to know exactly how long a specific feature takes to run, do your refactoring, and then measure it again. You can also use it to write code that's executed on the main thread, which is the one thread you don't want to block, and to make sure that if the code needs to be executed on the main thread and it can't delegate it to another thread, it stays below a given threshold. If you want to go further, there is an official Gradle plugin to lock the CPU clocks and grab the JSON result from the device. And you can also take a look at our GitHub repository, where we have a Gradle plugin to fail on high measurements. So this is a plugin that grabs the JSON results, parse them, and and compares the result with given values. And of course, if you want, you can use Jetpack benchmark on the Firebase test lab, and that way you can, get a pool of devices to use it. The last tool I want to talk about is the app performance monitoring. And the first two tools I mentioned are tools for developers. You control them, you know when you run them, and it's running like on your debug development application. But the idea is what's happening to the real users. The idea behind app performance monitoring is that you're going to get performance and runtime information from the production environment, meaning you're going to get the performance for your users as they live it. We have an SDK in Datadog which provides a few information, the logs, metrics, and traces. We're going to look into it. And it can bring you some information about how your application really behaves. So again, getting the application from getting the library in your application is very, very easy. It's just a couple of Gradle lines. And then you can start getting logs. Logs for us is structured information that we sent with a message, of course, because they are logs, but you can also attach information about events, measures, or state changes. It can be as easy as this, and you can. So we have this IE that'll use the same methods that you know from the Android log methods, but you can also add, as I said, structured information. So you can add attributes with any kind of data added to them. For instance, in a sample application, you can measure how long it takes from an activity to be created until you get to the onResume call, and send this information as a log, meaning that in our website, you're going to get this kind of log, and you're going to get it to display, for instance, this structured information where your time to resume was this much in nanoseconds. Once you have logs on a website, you can extract metrics information from logs, meaning that when you have numeric values, you can extract them to visualize the critical KPIs in dashboard. You can graph them. You can even get alerts on spikes or drops of those values. So for instance, you can say, I want to measure how long it takes. So using the activity to resume, time to resume information we add, we can graph them depending on the version of Android. And so we know that, for instance, we got a spike here in this value of how long it took to resume the activity on devices running on Android 8. Going further from that, you can also use tracing. So tracing is kind of the same thing as the trace view that I mentioned in the profiler in the beginning. So you can get traces across distributed architectures and have the hierarchy of method calls, and you can have performance information and debugging network errors. Basically, you can just add a simple interceptor on your OKHTTP client. That's going to create this graph. For instance, here we know that we had an OKHTTP request that started here in Android, and the rest of this graph is actually if your backend uses Datadog 2, you're going to see that the load balancer to this long, and then the underlying code spread across your different architecture, AWS or other system. This is how the network request behaved. And if there is an error that happens, you can also see them highlighted in red, so you know that if an error happens during a network call, you see exactly where it comes from. You can also trace custom methods if you want. Using this simple call, you can get the tracer and build a span. So a span is a single block, as we saw earlier. Start it, do your work, and then call finish, and then it will create this block timed around the work that you did. If you use our Kotlin extension, you have exactly the same thing that happens calling within span with the name of your block, and everything that's happening inside is going to be measured. You can get the result extracting from it too. And if an exception happens, it's going to automatically mark this span as being with an error, which is very, very nice to have. So the pros of this is that you're going to get real data with real use cases, real devices, and real network conditions. The problem with this is that if you want to use it, you need to have a large enough user base to have relevant data. The idea is not to track every single call of every user, but to get a trend of how long things take and get those trends divided by which device people use, which version of Android they're using, or other things. And because this is data that you send to a remote server that's measuring things on the user, you can't measure everything. So just tracing a few key information is going to be enough, but you can't have a full graph like we had in the profiler, a full graph of every single method code. So when should you use it? Mostly when you want to monitor key aspects of your app in the wild. For instance, like if you have a key aspect of your application, like the key value that people use your application for, and it needs to be fast, you're going to want to monitor this one and not the rest. This can help you understand how performance impacts your users and can be very useful in A/B testing. Because you can attach structured information to your logs or traces, you can also divide your graph between people with A or B version of a feature. If you want to go further, the library is open source on GitHub, so you can take a look at it and start opening issues or pull requests if you want to. And more features are going to be coming very, very soon, including real user monitoring, which gives you a more analytics view of how people navigate through the different screens of your application and what they're doing with it. Wrapping up with this, I'm going to give you a few key takeaways. The first one being that you want to measure twice and cut once. This is a saying that comes from carpentry and means that before you want to take action, make sure that your measurements are correct. So the idea is that you're going to verify twice or more your measurements to make sure that you have the correct one and it's not a fluke or a flakiness due to anything else. You want to choose the relevant tool to your use case. If you want to get a full graph of your method calls, you're going to use a profiler. If you want to see information from your real users, you're going to use an app performance monitoring library. And also, if you want to do an action, you need to analyze your measurements to know exactly what they mean. Sometimes measurements can report part of your application being slow, but sometimes it's just because the device had a very low battery, meaning that the CPU couldn't run as fast as it wanted, or the device was hot. And when the device is hot, the CPU is slowed down automatically to make it cool. So analyze your measurements to know if an action needs to be taken and what action needs to be taken. Here are a bunch of useful links. You can, of course, get them from the slides. Again, the slides are on SpeakerDeck, and they are also on the Android Makers virtual conference website. You have the Perfetto website, which allows you to read and navigate within Perfetto traces. You have a few documentation links on the benchmark library, and among others, how to run it on the CI and how to run it with Firebase Test Lab. And then you have our own library, open source repository on GitHub. In it, you'll find, among others, of course, our code, but there is also the Gradle plugin to read the benchmark JSON fail if they exceed the threshold, and the documentation to our log collection feature. That's it for me. I think we have a couple of minutes for questions. You can find me on my company on Twitter, of course. And I also have office hours. You can find them on the website. I can talk about testing, benchmark, or anything you want to do. And if you can't, if those hours don't make it for you, feel free to contact me on Twitter, and I'll be happy to arrange some time for you. So thank you, everyone. Now we can start taking a look at questions. The first question is, do you monitor battery performance? And if yes, do you use any tool like Battery Historian? For now, no, we don't measure battery performance because from what we know, most of the battery performance issue are grabbing the wake lock and doing network requests. For now, the way we work on our own library is that we never use wake lock, and we only use network when your application is in the foreground, and we try to only use it when necessary. So for now, we never had any use of this kind of tool, but this is actually something interesting we might want to look into in the future. Then the next talk is about Leak Canary. Leak Canary is indeed a very great tool to measure memory leaks. I didn't include it because this is not something that we do use in Datadog, because we make sure that we don't retain anything. I mean, we use it once in a while to make sure that we don't break anything. Leak Canary is basically, for those who don't know it, it's a tool that allows you to know when you have a memory leak, meaning that you keep a reference to an activity, for instance, or context in some part of the code that when the activity is not alive anymore, and that can make your memory grow. This is a great tool that can be used in addition to what I already mentioned, of course. It's just that we don't use it, and yeah, I couldn't add all the tools that exist out there, of course. Like you said, systress per photo seem to be very dense. Do you have a concrete use case in which you use them? A few use cases are to basically get information about concurrent algorithms. So basically, you have one case in which I used them is I had some several threads working together and reading and writing from the same values. And in some rare cases, I had a concurrent issue that I couldn't really understand, and it was only on some rare cases. It was not reproducible 100%. So what I did is I started tracing things until I got to reproduce the issue. And once I had per photo, you see that you can, have several threads bookmarked here. You can bookmark the several threads that you want to look at, and you can see them side by side, and you can know exactly what's happening when. And this helped me know what sequence of action from different threads caused the bug that I saw. Next question from Anthony. How can you be sure that a feature is optimized enough? How can you be sure that everything is optimized even for an old phone? It may work on one, but not another. This is a good question. And indeed, with the fragmentation of the Android ecosystem, it is not an easy one to answer. The way I would do it is to try to grab as many old phones as I want to support as I can, and run the benchmark tools on all of them and detect things. The idea is, I mean, if you want to go into this thing, the idea is to try to first look at the top selling phones from 4 years ago. And you take like 5 or 10 first results, and then you're going to look at their specifications: how much CPU, how much RAM, how much CPU cores, and all of that. And then you can try to find the common factors. You can try to find the lowest values and start to use them. The idea is to to vary how the devices that you're going to test on. Vary the API levels, of course, of Android. You need to vary the brands, because we know that some manufacturers like to mess with the Android framework. So some well-known manufacturers can have a very different way of behaving in some contexts, and try to vary also the amount of CPU, the amount of memory RAM, and also the screen size, because the smaller screen size means that you have a smaller view to render, meaning that you don't write as much pixels, so it's faster, of course. So, and having small screens and large screen on all of that. Maybe one last question, but I'll be happy to answer other questions on Slack too if you want. Come to find me. What are the advantages of Datadog over Firebase performance tool, which gives us the same breakdown? There is, I didn't test yet the Firebase performance tool. The idea is that Datadog didn't start with the mobile. It started with the web, and actually it started with benchmarking backend infrastructures. And the idea is that with Datadog, you can have traces spread across your whole your whole stack. Meaning that you don't get just the performance on Android. When you have a request that takes too long, you don't just get to know that, yeah, it takes too long on Android and you don't know what to do with it on the website. You can actually know that it takes too long because this part of your web stack is taking too long. Maybe it's a database read, or it's a login system, or it's something else, and you can track this. So yeah. So I think we are a bit over time. Again, thanks everyone for listening. Thanks a lot for Android Makers organizers for this virtual conference. And feel free to come talk to me during office hours or come talk to me on Slack. Thanks, everyone.